Solomon Saduma here. Thank you guys for watching these videos and for your valuable comment. We are starting on the next part of functions, and this is we now start with composite functions. To get on with it, let's start first of all by showing a function machine. Just revisit the function machine again for a few seconds just to get us started. Here is our function machine. It's a function machine because we feed in numbers inside there, and because of the rule for the function, which is basically the function itself, because of that rule we come up with something on the output. Okay, so for some input, a number we put in here, we'll get something on the output depending on what the rule is for this particular machine. Okay, so for example, I have a 2 there. If I feed 2 into the machine takes my 2, squares it, and multiplies by 2. So I expect if we square my 2 there, we square it. My 2 is the input, it's the x. So if I put it there, then 2 squared is 4, times 2 is 8, minus 3 times 2, which is 6. So 8 minus 6 there, I expect my answer to be a 2. Okay? All right, so that's what my machine does. It takes whatever I put inside and operates it according to the rule that I have assigned to it, and gives me an output on the other side. Okay, so this is what the function machine does. All right, here we go. We put a 2 there. You can pause the video and think about what you'll get on the outside. Okay, and it's gone in, and what do I expect to see out? I get 14. How is that? Negative 2 squared is positive 4, times 2 is 8, and then minus 3 times negative 2 gives me positive 6. So now I have 8 plus 6, which is 14. Okay, here's another one. If I put in 3 into the machine, what do we get? We should get 9, because if we put 3 here, we get that is 9 times 2 is 18, and this is minus 3 times 3, so 18 minus 9 there should give me 9. So this is what my function machine does. What about if I put some variable k? Well, k goes in, replaces x, and I should come up with 2k squared plus 3k. This is what this machine does. This we have discussed. But our interest now is composite function. So what happens if instead of just one machine, I put 2? So here's 2 machines now. Okay, what I'm going to do is I'm going to use machine F. I'm going to put stuff in the first machine. The stuff comes out, I get an output. And once I get my output there, I feed that output into a second machine called G. And then I want to see what happens at the end there. So here is the first one. Let's start with the 2. So what do you think will happen? You can pause the video and think about what we will get out there. All right? Okay, so if we put the 2 there, that becomes 2 squared. 4 times 2 is 8. 8 minus 6 is 2. So I expect to get a 2 here. So I expect 2 to come off here. Okay, so if that is a 2, now that 2 is going to be fed into the second machine, and if I put that 2 there, then 2 minus 4 should give me negative 2. So then I expect to have negative 2 there as the effect of passing my number through 2 machines. Okay, machine F and machine G. Yeah. Okay, so let's just see if this is true with this particular number. So I've put 2 there. It should come out through that point. Yes, 2. And I get negative 2 at the end. All right, so let's see another one. So the final output is a result of the effect of 2 machines, or 2 functions F and G. Okay, here's the next one. If I put negative 2, what do we get outside completely after it has passed through machine G? Please pause the video and try to see what you come up with. Okay, here we go. Okay, so if we put negative 2 there, negative 2 squared is positive 4 times 2 is 8, 8, and that's negative 2, so makes this positive 6. So 8 plus 6 is 14. That's why 14 came out through that first machine. So then we feed 14 into the second machine. Then we have 14 minus 4, which gives me 10. So that's how we end up with the 10 for the second machine. Let's try another one. 3, what do we end up with? If we do the same, first machine gives me 9, and I get 5 outside, because if we put 9 in, then the second machine takes the 9 and subtracts 4, and we get a 5. If we substitute, if we put k there, then I expect 2k squared minus 3k to come here, and then we will subtract 4 from whatever comes in there. So look, okay, and the final result is whatever that came in, subtract 4. So this is the effect of two functions on an input. The effect of two functions on an input is what we refer to as the effect of a composite function. Okay, that is two functions being used at the same time to come up with the result. All right, not a composition of function, but a composite function. Okay, so let's move on and see other things here. So we have two machines. We had that machine there, and we had this machine here. And what did the first machine do? The first machine takes whatever value of x you give it and turns it into 2x squared minus 3x. Okay, for example, which means that if that's the case, that means the result, which is y, also called f of x, is going to be 2x squared minus 3. Okay, let's see an example. So we said if we put in 1 in here, substitute, if the input is 1, we put that into this machine here, then we are going to end up with 2 into 1 squared minus 3, and that is going to be negative 1. So we can say that f of 1 is negative 1, like that. Okay, so f of 1 is negative 1. Similarly, if we put a negative 4 in there, well, we have negative 4 squared, which is positive 16, 32. 32 minus 12, is it 12? Right, so we get that, and working that out, we get 44. It's a plus because negative and negative there becomes a plus, and our answer is 44. So f of negative 4 is 44. All right, what about if we substitute g? Okay, where g is another, could be another function, basically this function here. So if we substitute g, I've removed the brackets with an x so that as not to bring too much confusion. So let's just leave it leanly there like g. All right, so if we put that there, then we get 2 into g squared minus 3g, like that. But now we can remove the g and substitute the value of g there. And if we do that, what do we get? We get that we end up with f of g is 2 into, we are substituting in the values of g into the expression, and we end up with something like that. And we write f of g is this. Now, in the GCSE A level, they use the symbol f of g of x, like that, which is what I really prefer. But the IB prefers to write this as f of g, and this is in bracket, of x, and x is put separately like that. And this is probably to separate it, to differentiate it from other composition of functions, like when they are added or when two functions are multiplied, which is different from the composite function itself. Okay, and so we write f of g of x is given by this. All right, it means that we are feeding g of x inside f. Okay, this is the function, this is the composite function that we normally refer to as the fog, F-O-G. Okay, okay, so that's what we refer to as the fog. On the other hand, if we are feeding f in g, like we're going to see here, then we call it the gulf. Let's just take a look. All right, so on this other side, g is such that x maps onto x minus 4. So if we substitute, so that gives me g of x is x minus 4, okay? Which means if I substitute 1 into this, then it is just 1 minus 4. The place of x is taken by 1, and I get g of 1 as negative 3. Similarly, if I substitute negative 4 on the g, we are substituting the same values of x as we did on the other side. Then we have minus 4, which should be negative 8. So we say g of negative 4 is negative 8. Okay? What if we substitute f instead of a real number? We substitute f, and we'll just keep it as f for now. All right? Then that gives me f minus 4, which is to say where there was an x, we remove and put f. So it becomes f minus 4. All right? And that gives me g of f as being, this is the value of f, this value there. So we substitute that in, and we come up with g of f of x as 2x squared minus 3x minus 4. And this is another composite function that we would refer to as the GOF. Okay? So this is how we find composite function, a function of a function. Okay? Here is a table with the values of functions and f of g and g of f calculated. So here, f of x is 2x, and g of x is x squared minus 1. Our job is to find the values of the output for this given input. In other words, what's the value for the output f of x? What's the value of the output g of x? What's the value of the output f of g of x and g of f of x? We want to determine these values. So when x is negative 1, what is f of x? Well, we put negative 1 there. We should get negative 2. Okay? And what's g of x when x is negative 1? So we take negative 1 and put it in the function g. So negative 1 squared, that's negative 1 into bracket squared, is positive 1. So 1 minus 1 is 0. We would expect the value of g of x to be 0 for an x value of negative 1, like that. What do we expect the value of f of g of x to be? Well, f of g of x, we already know what g of x is. G of x is 0 when x is negative 1. So f of 0 there, we go and look for f of 0, put 0 here. Okay, we should get f of g of x to be 0 as well. And what about g of f of 0? So we go look for f of negative 1. So when x is negative 1, f of negative 1, we found it as negative 2. So what is g of negative 2? So g of negative 2, put negative 2 here, negative 2 squared, negative 2 in bracket squared is positive 4. Positive 4 minus 1 should be 3, like that. So pause the video and try to fill up this table with the values of the functions f and g, and with the composite function f of g and g of f. Okay? Just pause the video and try to fill that table, and then check your answers with what I'm going to put here. All right? So when the input is 0, then we have 0, negative 1, negative 2, and negative 1. Check that that is right. If the input is positive 1, then we have 2. We should have 0, 0, and 3. If the input is 1.5, 1.5, then f of x, f of 1.5 is 3. G of 1.5 is 1.25. And f of g of 1.5 is 2.5. And g of f of 1.5 should be 8. If f of x is, if x is root 3, then f of x should be 2 root 3. G of x should be 2, okay? Because it's going to be root 3 squared, which is 3, minus 1 is 2. Okay, f of g of x is 4, and g of f of x is 11. All right, when the input is x, what do we get? When the input is x, then f of x should be 2x, right? G of x should be x squared minus 1. But what is the composite function f of g of x? Now we want to, because g is on the inside, the number, the function on this side, the g is inside f, right? So we are taking g and placing it in there. So we have 2 into bracket x squared minus 1. So you can say 2x squared minus 2. And if we do it the other way around, now g of f of x, meaning that we put 2x into g, we should end up with 4x squared minus 1. So just check that you got that right. So we have just been evaluating what we refer to as composite functions. Now we're going to try and do this proper. Here's an example where we look for f of g of x's. We look for f of g. This is supposed to be g of f, and f of f, and g of g. So we can look for all those. Let's look at examples. Given that a function f of x is x squared and g of x is 5 minus x, evaluate f of -1, g of 12, and so on. So let's start with the first one. F of -1 should be straight away. Put -1 there. -1 into bracket squared should be 1. So I believe I've worked this out. Okay, -1 squared, which gives me 1. So f of -1 is 1. G of 12, we have 5 minus the value of the input, which is 12, okay, which gives me -7. So g of 12 is -7. Next, we want to find f of g of x. F of g. So this means g is being fed into f, okay? The function on this side is fed into the function on the far left, okay? So if we do that, it means we are taking this and putting it in there. So we are going to have 5 minus x. So in place of x, we're going to put 5 minus x, like that. All right? So that means g squared, which is the same as 5 minus x squared, which is 25 minus 10x plus x squared. Okay? Part D, we're looking for g of f of x. So let's clean that up. G of f of x. So we take f of x and feed into g. So f of x is x squared. We put it in here, so we get 5 minus x squared. It's really, really simple, okay? So 5 minus f, which is 5 minus x squared, all right? The next one, we're looking for f of f. So we take f of x and feed it into itself. So f of x is x squared. So take x squared and put in there, and we have x squared squared, which is going to be x to the power of 4. Okay. Is that the last one? Yes. G of x. We are taking g and feeding it onto itself. So g of x is 5 minus x. Where there is x, remove and put g, just like that. And g of x is 5 minus x. So if you substitute that in, we have 5 minus 5, 5 minus x. I think that is supposed to be in bracket. So it's supposed to be positive x, I think. It's supposed to be positive x because we have 5, we are here, I'll do it here. So we have 5 minus g of x, but g of x is 5 minus x, and therefore this is 5 minus 5 plus x, which is x, okay? So the answer here, this is supposed to be in bracket right there. That's in bracket, which makes this positive, so please make that correction there. This here is positive x, okay? Right. Right. Here is example number 3. This is an examination style question. The function f of x is x squared plus 2 and g of x is x plus 14. Evaluate f of 0. solve g of x is 15. Find part 1, f of g of x and g of f of x. And lastly, solve the equation f of x equals g of x. So let's start this one at a time. The first part, right? Evaluate f of 0. F of 0. So we are given that f of x is x squared plus 2. So clearly f of 0 means where there is x, I remove and put 0. That's 0 squared plus 2. So f of 0 has to be 2. And that's my answer for f of 0. We have evaluated f of 0. We have found the value of the function when the input is 0. Right. Next part B was to solve g of x is 15. So if g of x is 15, well, g of x is x plus 14. So we are saying x plus 14 is 15. So clearly x is 1, right? So we have solved the equation g of x equals 15. Okay, next was for us to find f of g of x and g of f of x. So f of g of x, so f of g of x is, in fact, we go to f there, because f of x, we know that f of x equals x squared plus 2. So f of g must be g squared plus 2. Okay, now we go for the value of g there. That's x plus 14. So we'll say x plus 14, that's the value of g squared plus 2. And that is x squared plus 28x plus 14 squared, 196, I believe. 14, yes, 196. Then plus 2. So f of g of x has to be x squared plus 28x plus 198. And that is f of g of x. Can we find g of f of x? Let's look for g of f of x. Now, g of x is x plus 14. So g of f of x must be f plus 14. Now we go and look for f there. It's x squared plus 2. So x squared plus 2 plus 14. This is f of x. And therefore I have x squared plus 16. This is g of f of x in the IB notation. Okay? So these things are that easy. All right. Here is example number 4. Below are the graphs of f of x and g of x. F of x is in green, g of x is in orange. Okay? Evaluate f of 1, g of 3, f of g of 0, and f of 2. So f of 0, the value of x is f of 1. So the value of x here is 1. So we go to x value of 1, all right? And we read against f because we are looking for f of 1. So that means we read against the green one, and we can see that f of 1 is 3. So f of 1 here, f of 1 is 3, okay? G of 3, once again, now we go to, again, x is 3 now. So we go to the x-axis and allocate 3, x is 3. G of 3 is obviously 0. The graph is crossing right there. So G of 3 here is 0. Okay? Now we are looking for f of g of 0. So first of all, we must look for, we have to look for g of 0. Find g of 0. And then feed it into f. So what's g of 0? So we go to the value of x of 0. x of 0, and g of 0 is negative 1. So g of 0 is negative 1. Now we need to fit this into f. So this here is negative 1. So f of negative 1. Therefore, f of negative 1 must be what? So we go to negative 1. Well, do we know f of negative 1? No, we don't. So we say undefined, because our graph does not go onto the negative x-axis, okay? So therefore, g of f, which is to say f of g of 0, we write f of g of 0 is undefined. We say that because the graph does not extend onto the negative side for us to be able to tell what f of negative 1 is, okay? All right, lastly, f of 2. So we look for f of 2 and then feed it into f. Right, so f of 2, what is f of 2? So we are talking about the inner one. This is called the inner value. So what is f of 2? We go to 2 and read up on f. We get 1. So f of 2 is 1. And now this thing here is 1. Therefore, f of 1 must be what? F of 1, go to 1, and we get 3. And therefore, f of 2 has to be 3, like that. So that's how we reason in order to answer this question. Oh, there's a last one there. There are actually two more. G of f of 2. So we go to f of 2. F of 2 is 1. So we are looking for g of f of 2. So this is 1. F of 2 is 1. So g of 1. What's g of 1? So now we go to 1, and g of 1 is 0. So we write here g of f of 2. G of f of 2 is 0. What about g of 1? We go to g of 1. G of 1 is 0. G of 1 is 0. So therefore, g of 0, because that's 0 now. That's not nice. So, excuse. So this is the same as g, not nice still. So this is the same as writing g of 0, because this part here, g of 1 is 0, and so g of 0, and g of 0 is negative 1. So we can conclude that g of 1 is actually negative 1, like that. Okay? Hope you are able to understand this, and that you can try a few of the questions I've put forth for you to attempt. Where are those questions? Here we go. They're exam style questions. Okay, so the first one there, problem set number 1. The functions f of x is root x and g of x is 2x plus 1. Evaluate g of negative 1. Solve f of x, everything squared, equals g of x. I want you to try that. Then find, for part 1 there should have been 2. Find f of g of 40. And the last one there is to find the implied domain and the range of y is f of g of x. So please try this out and let's see what you come up with. Question 2, again, look at that. You will pause the video and solve the problem. Okay. Question number 3, an exam style question. All right. The function f is such that f of x is kx plus 3. This is a real exam type question. The function g is given by 2x minus 4. Given that g of f of x is 34, find the value of k. Okay, so that is a typical exam question. You're looking for the unknown value there, k. All right, I think this should be the last one. Given that f of x is x squared plus 2x plus 1, that's quadratic. It's actually a perfect square. Show that f of x plus 2 minus f of x is going to be 4x plus 8. Okay, so try to solve that and show that it simplifies to 4x plus 8. Okay, here is another one. This is graphical. So find g of 2, f of g of 4, g of f of 2. Okay, so find those and let's see what you end up with. Okay, I believe that's the end of the lecture. Thank you very much for watching. I'll see you for the next video. We are starting on inverse functions. Okay, thank you so much. See you later.